Hi, everybody. I'm Aaron from Solace, and I'm here to talk to you today about event-driven design and event-driven coding. Coding how to be event-driven. Can you see my slides? Just Matt, is that good?
Yep.
Is it?
Looks good.
Okay, excellent. All right. So, and some dragon boat. So, events are pretty important, right? Events are the kind of the center of the universe. Everything in the universe is event-driven, right? Every time like an inventory is updated in your kind of inventory system, every time a sensor trips off in your infrastructure somewhere, an event is being generated. You know, every time a stock price ticks, that's an event. Everything in your infrastructure can be represented as events these days. And modern enterprises are moving towards this fully event-driven kind of architectures and systems. So events are important. But, you know, backing up a little bit here, you know, didn't always used to be this way. Software has historically been kind of monolithic, proprietary, batch-oriented systems, usually with the database kind of at the center of its core. But we started to move away from that, like looking at more decomposing these big monolithic systems into microservices, but that just increases the complexity in terms of communication between all these different components. And there's also a move towards more real-time communications, right? So rather than, you know, at the end of the day, kind of your inventory being updated or your bank account being tabulated, you know, customers, businesses are requiring things to be real-time, updated constantly, and that's just driving up the volume of data that's being sent around between all of these different systems. So looking for ways to increase efficiency and turning towards more event-driven architectures. You know, and as things have moved into the cloud, you know, we've been looking for ways to make sure how these kind of different components can talk to each other. You know, the internet was built on, you know, REST over HTTP. You know, everything understands REST. Every web server, every proxy, every firewall. So, you know, when we moved to the cloud, it just seemed like a really easy and quick way to make, you know, our applications talk to each other. You know, RESTful APIs. But is REST always the best? You know, not necessarily, right? There was a need to invent more kind of efficient asynchronous bidirectional protocols like WebSockets, and that's what we're going to talk about today: contrasting event-driven coding and RESTful applications. So I'm just for something a little bit fun, I'm going to throw in this just Dragon Boat game. So let's build ourselves a distributed application, internet-enabled application. We're going to hopefully have a couple different players from a couple around the world. This should work for wherever you are. So you're going to need either your phone or your laptop, maybe a Chrome tab or something. And you're going to head over to, let me just switch it over here. You're going to head over to this URL here. So sg.solace.com/db. And you're going to essentially join my little Dragon Boat race. And we're going to use this as a bit of a kind of an explainer as to how this all works. So I'm just going to give it like a minute or so for people to kind of join in. Hopefully this all works. All right, we got one joiner so far. That's excellent. I don't know how many people are watching this thing, so hopefully we have at least a few. I'll give it a few minutes. So again, either your phone or your laptop, Chrome tab would be fine. Just type in this URL and it should add you to the team and it should assign you a team color. So essentially what's going to happen is I'm going to start the race. There's going to be basically a little countdown. And once the race starts, all you have to do is either tap on your phone or click anywhere in the background, anywhere in this blue area, and it will row your boat. Every time you click, you'll row the boat. And so the first one across the finish line wins. And if you are one of the top 3 rowers at the end of the game, we're going to have give you a ranking. If you're the top 3 rower, please ping me on Slack in the All the Talks Slack channel or personally, directly, and I'm going to send you a little prize for the top 3 people. So screenshot your top 3 placement and send it to me on Slack. Okay, so that's pretty good. 24 people. I'm gonna start the race. So essentially, yeah, when it starts. Countdown, just start tapping anywhere as fast as you can, use as many fingers as you can, and here we go. All right, and they are off. Tap, 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 tap. All right, yellow and green are pulling ahead. Pink is in behind. Oh, yellow is actually pulling ahead quite a bit. Come on, pink, come on, orange. Tap as fast as you can. Many fingers as you want. Tap, tap, tap. Oh, it's gonna be close. It's gonna be close. Yellow wins. Congratulations, yellow team. All right, so if you were the 1, 2, or 3, wow, someone clicked very, very fast. So if you're in the top 3, let's say the top 5. If you're in the top 5, take a screenshot of your ranking, send it to me on Slack, and I'll get in touch with you for a little prize afterwards. Okay, so simple little, silly little game, right? If we're gonna build this thing, what would we need? Well, you're gonna need obviously some kind of somewhere to host this thing, some web server. You're gonna need some kind of controller application that is kind of managing the whole state of the game, assigning teams, starting the race, keeping track of who's in the lead. You're gonna need some kind of display, and obviously some kind of mobile front-end device for all you players out there, right? Now, this talk could have been done in the JavaScript stream or the Java stream. It could go either way, because I think most of the stuff in this talk is actually fairly applicable to both. Now, because this is an internet-enabled application, can I use REST? Can I use REST to make all of this game essentially work? Now, REST over HTTP is very common, and it's very common in even modern microservice architectures. Everything has a REST API. Everybody's used to get and post and put and patch. Great for making service calls, especially when you want a response coming back from the other side. The thing is, though, REST architecture is client-server by definition, right? It's from the backend, it's from the client into the backend, not server to client. REST over HTTP is point-to-point. You're talking to a specific URL or URI when you make your address. And HTTP at a network level is actually a synchronous protocol, right? You're blocking, waiting for that 200 OK or that 503 to come back from the other side. So is REST always the best? Sometimes yes, sometimes no. It's not always the best. So let's take a look at some possible issues looking at our game as to where maybe REST doesn't quite fit the bill. So an easy one to start off in a microservice architecture is service discovery. If you have some kind of centralized service discovery mechanism, then it's kind of easy to find where things are running, what services are available to your application, to find out where things are. But if you didn't have this, how would your REST application go about kind of finding where the game is? What if there are multiple games? What if games are starting and stopping dynamically? How would you do that with a RESTful-based application? I'm going to show you a cool way to do it using event-driven publish subscribe later on. How about the start of the race, right? So basically, we've all joined the race. We need some way of saying, okay, we're going to start the race, which is essentially a server to client kind of communication, right? I need to signal from the back end to all of the mobile devices out there that something's starting. So if you're using REST, that'd be quite difficult. So one option that is commonly used is to poll, right? All the mobile devices will poll the back end to find out if, has the race started? Has the race started? Has the race started? Every 10 seconds. But if it's every 10 seconds, you might miss the start of the race. So instead, now you poll faster. You poll every 1 second. Has the race started? Has the race started? But now you are essentially just hammering your back end with all these no-op, essentially, queries. So polling is never an efficient way of gathering data and checking for state change. And we're going to talk about that a little bit later on. Now, because this is like a simulation or a really high-tech simulation, we want to make sure that we send each and every event as it occurs, right? Each and every row in case there's a close finish line finish. So if I'm using a synchronous protocol, if I'm connecting over the WAN and I have, say, a 100 millisecond round trip time, I can only send about 10 events per second with that kind of round trip time. So it's not always using a synchronous protocol like HTTP is not always the best. Maybe I want to use a protocol that's meant for streaming. It's meant for asynchronous delivery. A couple stretch goals could be kind of like client-to-client communication. What if everybody on the pink team or everybody on the green team wanted to talk to each other? Some way of kind of not going through the web server. How would you do that with REST? That'd be very difficult. All of our mobile devices are scattered throughout the internet. How would you find them using REST? It's much more difficult. And how about, for some kind of way of doing analytics? You want to capture all of the data as it's flowing over the game, without changing any of the code. Is it possible that we can kind of listen to all of this data flowing through the game, as it's happening? Now, we could listen to, if it was REST and we're using a web server, we could scrape the log files off that web server. But, is there a better way to do this? Is there a better way? Yeah, so let's park that for now. And let's just talk a little bit about event-driven design, event-driven coding. So what does it mean to be event-driven? Now, if you're a software developer, oh, wait, hold on. I'm going to back it up. What does it mean to be event-driven? Right. Real-time, this is kind of my opinion of it, but people might differ about that. But real-time, reactive, asynchronous, non-blocking, and decoupled or loosely coupled architectures. So this is all of these things will give rise to producing applications that are more efficient and higher performance event-driven applications. But it's not always necessarily easier. Sometimes designing to be event-driven, including asynchronous, non-blocking, the code can be a little bit more complex. It's not as easy, but you do get benefits from that. Now, if you've ever done any GUI programming out there, like Java Swing or any kind of GUI toolkit, you've already done event-driven programming, right? Every time you click a button or move a window or resize something, events are being fired from your GUI framework into your application for your application to respond to, you know? Same thing with video game design. When I was in high school, we used to make video games. So every time, you know, the fire button's pressed or the joysticks move, you're responding to these user events. But events exist everywhere. You know, every time you tap your card to pay for, you know, your subway, or every time you push a button for an elevator, every time something changes state in your system, every time your database gets updated, these are events that can be, you know, sent and broadcast, and other systems, downstream systems that want to know about these events, they can like kind of listen to that event as it occurs. But in terms of coding for events, we're not always taught this way early on. You know, when we first learn programming, you know, we call a method. The method gets put onto the stack. It runs some computation, and then when the result is done, you know, it kind of returns, pops off the stack, and you know, we're in the same thread. You know, it's kind of like a blocking call. It's almost like a service-oriented architecture. But when we design for event-driven, typically it's done with non-blocking calls, and you're going to use callbacks. You're going to register callbacks to asynchronously respond to you when the computation, for example, is complete. So let's take a look at a couple design patterns. Some of them you may know, some of them you may not, that are used in event-driven coding. So the observer pattern, or the subject observer pattern, this is the GUI pattern, right? This is the, you know, I want to click a button, and you want me to tell me when this button is clicked. So you're going to have a subject. This is perhaps your button. You're going to have some observers. This could be your applications. And every time this subject changes state, it notifies the observers that something is occurring. This way, your observers aren't constantly asking the subject if its state has been changed. You know, what kind of weird GUI toolkit would it be if you had to constantly poll your button every couple seconds to find out if it's been clicked? You know, that's a very inefficient, very strange design. Just tell me when something has occurred, and I can react to that in an event-driven way. So the observer design pattern. The reactor pattern. This is used a lot in I/O type applications, web servers, for example, and it's meant to increase throughput and reduce the number of threads possibly that you have in your design. Older web servers had kind of like one thread per connection, and it kind of relied on the thread scheduling of the OS to kind of manage kind of which thread was being serviced. But you know, that can cause a lot of context switching and, you know, be rather inefficient. So the reactor pattern is essentially you might have events coming in here. You know, this could be a TCP socket or some kind of stream of events. You're going to have a thread, a single thread, as an event loop that's actually listening to these events and then dispatching them out to a bunch of scalable worker threads in the back end. So as the load increases, as the rate of events coming in increases, you can scale out your number of worker threads here, makes this dynamically. These could be microservices, for example, right? And basically, once they're done computing this data, you know, they're passed back to this event loop, which can then request it. So your processing is not happening here. This guy is just dispatching data and requests between these backend services. So it makes for a very reactive, very responsive design. And it's used typically in a lot of web servers, reactive, Nginx, Node.js uses this. A lot of high performance consuming applications that need to process a lot of data use the reactor pattern. So the publish subscribe pattern, this is not really a software design pattern. This is more of a communication pattern. And it's used kind of to decouple your publishers and your consumers of data. So similar to the observer pattern, this one is used to notify downstream consumers that an event has occurred. And this is typically done using an event broker. And this is what Solace, my company that I work for, this is what we produce. We make event brokers. So you're going to have your applications that are producing events. They send a message as the piece of data, and they send it to a topic. And then consuming applications or consuming guys that want to know about this event that occurs, they subscribe to this particular topic. They subscribe to get these notifications so that when it's being done, they are notified. So the event broker, the guy in the middle here, basically handles all this dispatching, and the consumers and the publishers don't have to know exactly who is sending the data or how many people are actually receiving it. So very decoupled architecture and allows for very scalable architecture, as we're going to see in just a bit. So what is an event broker? It's a middleware component that sits kind of in the middle of your applications, and it allows you to do different kind of data exchange or event exchange patterns, such as request reply, which is more the HTTP RESTful style, publish subscribe, which is kind of one-to-many style of distribution, point-to-point, which is one-to-one kind of locked in distribution, possibly replay. A number of different styles of sending data between applications using kind of a centralized broker-based architecture. Now, it should be allow for efficient communication. You want it to be efficient, bidirectional, asynchronous, for example. Now, there are a lot of players in this space. There's some that are cloud-based only. There are some that are on-prem only. There's some that are commercial, some that are open source, some that supports only web stuff, some that supports only, kind of TCP-based communication. So, Solace kind of does a bit of everything. I'll give you some links at the end if you want to go check it out. Now, previously, there was a lot of proprietary standards with regards to kind of event-oriented or message-oriented like communication. But like REST, how REST became a standard and the internet kind of got built on it, there are now standards in messaging or event communication as well. So two of the big ones, kind of open source ones, are MQTT. This is a pub/sub protocol, lightweight protocol that was built for IoT. AMQP is a little bit more heavyweight, a little more enterprise grade in terms of standards. Obviously, WebSocket is a transport, JMS is an API. So these are not all equivalent, but there are standards that have emerged and are very kind of common now with regards to building applications that do kind of pub/sub and event-driven distribution. Now, if you've ever used a messaging API or an event-driven API, this is very much a very basic idea of what it actually looks like. You're going to have an API that allows you to connect to some broker, some host. You're going to be able to disconnect. You're going to want to subscribe or unsubscribe to topics. And this is how the consumers receive data. If you're using persistent messaging or persistent data, you might need to have a queue in there to act as your persistent storage. When you send a message, you're going to publish that message onto a particular destination, send it to a particular topic. And this on-receive, this is a callback interface. This is what makes your whole application event-driven from a consumer perspective. When a piece of data arrives for that consumer, this on-message or on-receive method will be run by the API to signal that something has occurred. Great, here's your piece of data, here's your message. It's all event-driven. I don't have to be polling a broker with my consumer to find out if there's new data. Now, topics are used to route the data. In Solace, we do topics this way. They're kind of hierarchical, which allows for very descriptive kind of ways of kind of sending data and tagging the message when you get sent. It's hierarchical, as you can see, which allows us to do cool things with wildcards. So some pub/sub brokers don't allow the use of wildcards, or kind of topics are considered very flat, very much like a label. Whereas in Solace, we have the ability to use wildcards. Same with MQTT, if you're familiar with that as a protocol, they also offer the ability to do wildcards. So a consumer can use a wildcard subscription and receive many, many topics that match that particular wildcard. Think of it as a very basic or simple kind of regex expression. Now, okay, so I got these topics. I have all these topics between my applications. I've designed them all. Now, how can I do code generation from that? I don't maybe want to write, use your API. I just want to use something that's a little bit more generic. In the REST space, this has existed. A lot of REST applications tooling exists because of OpenAPI, Swagger. Many of us know that you can specify this definition of your REST application, and you can go off and do code generation. You can do management of this governance, and you can kind of look at it's very easy. There's a lot of tooling that's built for RESTful applications. But if I'm building event-driven, a publish-subscribe application, what exists for doing that? So there's a new initiative, fairly new initiative, called Async API. It's open source. Quite a few of our friends and competitors are partnered with these guys, and it allows you to specify a specification to kind of govern the publish and subscribe semantics in terms of topics, but also in terms of the payload of what data your applications and your distributed applications are expecting. And so Solace, our company, has gone off and built this kind of portal that is doing for event-driven what RESTful applications have with kind of like API management and API portals. So it allows you to do documentation, design. As an architect, you can design an application just using kind of like a point-and-click interface. You define your topic spaces, and all this stuff that you can do with a RESTful application, you can now do using EventDriven. So check out Async API. I'll put a link up at the end. But very, very cool stuff. Allows you to do things like code generation for Spring Cloud Streams, for Node.js, Go. Takes the specification and builds boilerplate code that allows you to essentially do the marshaling, unmarshaling of the data, so that as a developer, you just now have to write the business logic. All the boilerplate code gets kind of made for you, all the publishing and subscribing and the topics. That's all managed by your code generation. You just need to write the business logic there. So pretty cool stuff. We're very excited to be partnered with Async API. Go check that out. As a developer, it's pretty neat. So going back quickly to our Dragon Boat, just before we wrap up here, we've talked about publish, subscribe, event-driven, kind of one-to-many communication. If we're going to build this, if we're not using REST, how would we build this in a better way? Well, I would say use publish, subscribe, use a Solace event broker, or maybe some other event broker that you want. One that supports WebSocket connections, one that supports multi-protocols and multiple languages, Java, C, C#, .NET. Obviously, there's different ways of doing this, but this is how my game actually made. So even though this is actually, the game was running on a Solace broker, there's actually no Solace API code in there. So all of the kind of like interactions we're doing was actually using an open protocol called MQTT. And we support MQTT, AMQP, REST, and a couple other ones as well. So here's the topic space that the game actually uses. So you can see it's hierarchical. There are kind of IDs at different levels, and it allows all of our applications to communicate in kind of a many-to-many kind of mesh-based, event mesh kind of architecture. So going back to those 5 previous kind of issues that we had, service discovery, when I start the game, when I start the backend controller, it subscribes to what's called a well-known topic. A topic, essentially a service that's saying, hey, this is my well-known topic. When your phone connects, it publishes one message on that particular topic. And even if I have multiple race engines running in the background, because of publish subscribe one-to-many, every one of those race engines will get a copy of that one message, and they can then respond back with their details. So a very easy way to kind of find out who is out there running by using publish subscribe. At the start of the race, so when we've all joined one race, we all subscribe, all of the phones out there, we all subscribe to a race topic, a special ID, that now all I need to do with my backend controller is send a single message on this particular special topic, the race ID / marks, and all of the phones out there, because you're subscribers, will get it. So again, using publish subscribe, but now in a reverse way. So from server out to client. So bidirectional communication. Being able to send each and every row event, choosing an asynchronous streaming protocol, such as MQTT, such as AMQP, or one of Solace's protocols, allows you to send many, thousands perhaps of messages per second, even across long links, not waiting for that blocking call to come back. So from a communication perspective, choose a protocol that's right for you. And from an application perspective, ensure that your thread is not blocking, waiting for each individual response, the acknowledgement to come back from the other side. So build your application and choose your communication protocols to be as efficient as possible. And finally, I guess the kind of the many-to-many, the client-to-client communication. Again, using publish subscribe. If everybody on the green team subscribe to green topics, just need to publish one message on that green topic, and everybody will get it. So publish subscribe is a very flexible way of making your applications communicate and ensure that data is going to wherever it needs to. And finally, the last one was the analytics, right? Could we build something where we can listen to all of the data going across our mesh, our application, without actually changing any code? And again, because we're using publish subscribe, I can now just create a new consumer. Perhaps I'm using a queue if I want to use persistence, and I subscribe it to all of the topics. So this is in Solace, this is essentially a multi-level wildcard. It's saying any data that starts with that first level of boat, I'll get a copy of it. And now this other endpoint now just receives a copy of everything without changing any of this code. So a very future flexible forward kind of design using publish subscribe. So check out, thanks very much. I think that's about the right amount of time. Here's a couple links. The Dragon Boat code is on GitHub. It is JavaScript, so perhaps the Java people don't really care too much about that. Check out some of our Spring Cloud Stream code generation stuff, where we can take an async API schema and generate code from that. And in the middle here is a link to the Solace developer portal where we have lots of kind of information on different APIs and protocols and all sorts of stuff. So thanks again. And just a reminder, the top 5 people who won their Dragon Boat race, just send me a screenshot on Slack and I'll get back to you. So
all right. So perfect timing.
Thanks, Matt.
Well done.
Okay.
We have a number of questions, so I'm going to start just in the order that they've been asked. When would you use Java event-driven rather than client-driven or JavaScript programming?
So it really kind of depends. I am a Java guy by trade, so a lot of my backend knowledge, like when I usually deploy onto a server, I'll use Java for the backend. And then for the GUI side, I'll typically use JavaScript because it's much easier to kind of do things on in a browser. So if you have a broker that supports both JavaScript and Java APIs or protocols, it just allows you to mix and match and choose whatever you want. So in Solace, we support multiple protocols, and each one of those protocols has APIs for a bunch of different languages. So you don't necessarily have to choose only Java or only JavaScript. You can truly have a mix and match, kind of choose your own flavor. Which allows you to choose like a Python API or a Go API and kind of mix and match and build this application, kind of choose whatever language that you want that you're most comfortable with.
Cool. So out of the open standards you mentioned, what's the easiest one to use for someone that wants to build their first event-driven app?
MQTT, by far. It is great. I use it for all my demos now. It's a very lightweight publish subscribe API. The APIs are very, very simple. Solace APIs, we have a lot of features built into our broker, lots of really cool stuff. But if you don't necessarily need that level of complexity, I would say MQTT, check it out, lightweight pub sub. It supports the topic hierarchies. It supports wildcards at different levels. And Solace supports both that and other protocols. So you can start with a Solace broker, or there are other MQTT brokers out there as well. But yeah, MQTT all the way for sure.
And I'm assuming because you have a link to the Dragon Boat code that's open source.
It is. Yeah. It's okay. It's not the best code to learn how to do event-driven coding. Like probably the majority of the code in there is kind of state machine and graphics and stuff like that. Like the actual publish subscribe. Like most applications, the amount of I/O code is usually very, very small, right? Most applications are more around graphics or user interface or
right.
The logic of it, right? So the amount of code that's in there just for the Solace parts or the MQTT parts is actually quite small. But yeah, if you want to take that code and just kind of take a look at it, it's pretty bad. It's my code. I never really cleaned it up much. So help yourself.
I thought it was a great way to start a presentation, right? You get kind of the audience involved and everything.
Exactly,
so nice
exactly.
Work there.
I'm glad we had some people join in. So excellent.
So
any other ones?
Another question: what benefit do I get using Solace over another broker like Kafka?
That's a pretty long. So Solace offers kind of more multi-protocol standards. We do support replay, which is kind of a fundamental requirement in Kafka for their kind of recovery mechanism. We offer a cloud-native software broker as well as a hardware appliance. So like if you're an enterprise customer, you can scale up very easily. Kafka is more for Kafka is more like almost as a database, right? It's really kind of built themselves as a database, as a persistent event store. Kafka essentially becomes a consumer of data off of Solace. We have many customers that use Solace as their kind of many-to-many event-driven mesh between their applications, and Kafka will just be a consumer off of that, pulling all that data down into putting into their analytics and stuff like that. On our website, I'm sure if you just Google Solace versus Kafka, we have some some documentation there. I have a video on YouTube actually that kind of talks about in terms of topics. There's some stuff out on the web, so I'd say just Google it, and you'll get more information. So.
All right, so you got 1 minute for this last one. Does Solace provide an event portal to enable design of architectures, similar to an API portal you talked about?
That's right, yeah. So if you head over to cloud.solace.com, you can sign up for a free cloud account. We send you an email, gives you the notification. And in our cloud console, it allows you to spin up one free broker that gives you like 50 connections. But it will also, you can actually ask and request access to the event portal. So our event portal is actually being, it's brand new. I don't think it's even gone GA yet. It's going GA, I think, in a week or two. And it will allow you to do things like design applications, schemas, topics, and click and drag basically the interactions and the relationships between them. So I wish I threw in a slide or two just because I did actually have some time. But yeah, check it out. Again, maybe on YouTube, I think we do have a couple of videos that kind of give a demo of it. So if you go to the Solace YouTube channel and check Event Portal, you'll be able to see kind of a demo of what it looks like. So
cool. So if you want to throw some links in Slack in the Java track,
can do.
#track-Java, that'd be great. Thanks.
Okay. All right.
Take care.
Thanks, Matt. Thanks, everybody. Okay. Bye-bye.